Completing the square. Completing the square. How do we complete the square for a given algebraic expression? How do we complete the square for a given algebraic expression? Now, let us consider the questions or the expressions given here. So the question says, complete the square for each of the following. Complete the square for each of the following. So for the first one, we have x squared plus 6x. X squared plus 6x. For the first one, so we have x squared plus 6x. Now to complete the square for this, the variable here is x. So we're going to write is equal to x plus half of the coefficient of x here. Coefficient of x here is 6. So half of 6 is 3. So you put 3 here. Then all squared. Then we introduce minus. Minus, then square of whatever number we have here. We have 3 here, so we put 3 squared here. So we can rewrite x squared plus 6x will be equal to x plus 3 all squared minus 9. So this is the answer. This is the answer. So if you ask to complete the square for x squared plus 6x, this is our answer. X plus 3 squared all squared minus 9. We have a complete square here. Then we have minus 9 here. So if you ask to complete the square for x squared plus 6x, this is our answer. This is our answer. Sometimes they ask students that what number must be added to x squared plus 6x to make it a complete square? What number must be added to x squared plus 6x to make it a complete square? The answer to that is any number you find in front of this minus is the number you're going to add to x squared plus 6x to make it a perfect square. So we have this minus 9. We have 9 in front of this minus. So this 9 is what we're going to add to this. In fact, if you transfer this minus 9 to this side now, we're going to have x squared plus 6x plus 9 is equal to this. And that will make it a complete square. So let's take the second question. The another thing, for us to complete the square for any expression, coefficient of x squared must be 1. Coefficient of x squared here must be 1. If it is not 1, as in this case now, coefficient of x here is 4, we need to readjust. We need to readjust the expression so that the coefficient of x squared is 1 before we can complete the square for it. Now let's take the second expression. Question number 2. So we have 4x squared minus 12x. We have to complete the square for this. Coefficient of x squared is 4. It is not allowed. We need to readjust the expression. So doing that, we're going to have 4 into x squared minus 12x all over 4 x. So you try to factorize 4 here. Bringing out 4 here, we need to introduce minus 4 here. So we are trying to do this so that coefficient of x squared will be 1. So this is the same thing as 4 into x squared minus 3x. So this is the factorization. Sometimes we can, actually, the step here could be omitted. We can actually move from here to here. What is 4 is common here. We have 4 here, we have 4 here. We can actually, directly from here, we can actually say, factorize by saying 4 into x squared minus 3x. We can actually do this. But there are some algebraic expression wherein we may not have a common factor here. So that is why we are showing this. So we are trying to make the coefficient of x squared to be 1, first and foremost. Now, we are asked to complete the square for the expression. This is the expression 4x squared minus 12x. We have to complete the square for it. From there now, so we have this. We have this already, 4 into x squared minus 3x. So we complete the square for what we have inside alone. So doing that, we're going to have 4. We're going to have 4. This is x minus half of the coefficient of x here. Coefficient of x here is we have 3 here. We have 3 here. As a number standing before x here, we have just 3. Let us leave this minus aside. We have 3. So half of 3, so that would be 3 all over 2. All squared. Then minus, we introduce. Then square of whatever number you have here. We put after the minus. So doing that, we're going to have 3 all over 2 all squared. Then you close the brackets. You close the brackets. So completing the square for what we have in this bracket, x squared minus 3x will give us what we have in this bracket. So when you tidy that up, so we're going to have 4 into x minus 3 all over 2 all squared minus 9 all over 4. So we have this. So from here, we can open the bigger bracket outside. So doing that, we're going to have 4 into x minus 3 all over 2 squared minus 9. We're going to have this. The minus 4 here, when we open the bigger bracket outside, the 4 will come here, it will also come here. And that 4 will cancel, this 4 will cancel the 4 here. So that's why we have in a minus 9 here. Now, from here, we can actually rewrite what we have here as 2 raised to the power 2 into x minus 3 all over 2 all squared minus 9. So this is same thing as 2 into x minus 3 all over 2 all squared minus 9. Remember, we have 2 here as the power, we have 2 there as the power. Now we can actually write everything here as this, going by one of the laws of indices. So from there, we're going to have, when you open the inner bracket, we're going to have 2x minus 3 all squared minus 9. And finally now, therefore, remember we started from here. 4x minus 12x. So that means, in conclusion now, 4x minus 4x squared minus 12x will be equal to 2x minus 3 all squared minus 9. So this is the answer. So to complete the square for 4x squared minus 12x, our answer will be 2x minus 3 all squared minus 9. So this is the answer. Sometimes they ask students that what is the number? What number must be added to 4x squared minus 12x to make it a complete square? What number must be added to 4x squared minus 12x to make it a complete square? This is a complete square here. The number is whatever number we have in front of this minus, which is 9. It is obvious, this minus 9 here, now when you transfer it here, it becomes plus 9. And we're going to have 4x squared minus 12x plus 9 is equal to 2x minus 3 all squared. So this is a complete square here. So this is how we complete square for algebraic expression.